So once again, you're welcome back to Integrated. This is Mathematics. So I'm gonna continue my last session. This is session 3, statistics and probability. Right. So as I discussed, we were talking about probability mass function. So today, we want to talk about probability density functions. So I have taught you that the probability of these scenario will be expressed by, I'm going to talk about this particular bar, right? At this moment, once the random variable is existing between xy minus delta x upon 2 and xi plus delta x upon 2, we can say how these height of this bar will say it will illustrate probability mass, right? So times delta x, width of this class, right? So once I make it a probability density function, it means that I'm gonna switch it into continuous random variable, so it becomes a very smooth curve. How can I do it? So that's pretty much easy to do. If I make height of the probability mass the subject, it will be look like that's pretty much easy to derive. This is what we were looking for, right? So that's what we were looking for upon delta x, right? So we can let delta x goes to 0. Once we let delta x approach to 0, and this bar will tend to a straight line, not a straight line exactly, but that is pretty much close to very tiny slide. That is really tiny slide. Once we let each of these sticks be the type of very tiny candles, so it will be look like let me just figure out it, this type of distribution. Let's assume that, right, okay. So what happens, that's not a straight line, but that is really pretty much close to a straight line. There is a width, right? Okay. So let me simplify it once again. We can say pmf times the height times the probability mass function. This says probability mass functions. Let me pick it as the probability mass function f of x, right? This function may be f of x equals to y, right? So y equals to f of x times here delta x is going to be equal to the probability from here, okay? Same as I explained before, xi plus delta x upon 2. So then I'm gonna let it approach to, let it tends to delta x goes to 0. We need to let delta x goes to 0, and so you can see these are probabilities, right? And so I'm gonna give the summation of a bunch of these tiny slides, maybe from here to here. After each of these things, I hope to show you how to do the calculation, just like our integration, right? That is pretty much similar to integration, because here also is explained, the integration is explained, because the probability mass, once you find out the integral of probability mass function, then you can find out probability. under that curve, right? So this all contrast between the probability mass function and the probability density function is we're gonna let it probability density function by allowing delta x to go to zero, right? So then get the summation. Hope you see it right. Okay, get the summation from here from a to b once f of x times delta x limit delta x approach to zero. Here this is what is going to be equal to summation here really this is xi starts for his journey from little a to b all the way from here to there, right? And this is nothing is probability xi minus delta x upon 2 is here less than here. This is between xi plus delta x upon 2 and xi minus delta x upon 2, and get the summation as I defined and let delta x go to 0, then only you can represent here probability density function. So then we have let it here we could make it probability density function, right? And now this can be rewritten as the integral. Once we concat this summation and limits, it forms the integral, right? Integral of this probability density function will give you the probability, right? The probability. This is from little a to b. So here you can see let me pick another color, right? Equal sign probability between little a and little b. Could you understand it? Yeah, sorry, I'm performing I'm not performing online conference, right? Okay, so hope you could get an idea about this probability density function, how I have made probability mass function the probability density function. So how we can work with this probability density function. Once you integrate probability density function, it will give you probability. It stands for continuous random variable. That's the sole contrast between these two, right? So in next video session, I hope to explain expected value of continuous random variable and discrete random variables, right? So it means pmfs and cdfs, or sorry, pdfs, right? So wait hopefully and patiently. If you're having any doubt, please be kind enough to let us know, right? So put it as a comment, or even you can contact us with our official website, right? Okay, so as usual, I'm Sapamal Sena. Thanks for watching.